say that it's recording.
Oh.
Okay, yeah, recording has started now. So yeah, where should we start, man? Do you want to start like from the beginning, like to explain like should I start from where the difference is between Java and C++, or I should just explain what Java is all about? Like
Uh,
starting from why do we need Java? Why do we need programming languages, etc., whatever.
you can go you can just go straight to Java. Yeah.
Okay.
Yeah.
So what I'm going to do, right? I'm going to let me see, draw.io. So I'm gonna use draw.io to sort of like illustrate the things I'll be talking about so that it's easier for you to understand if you can visualize it.
Yeah.
Yeah, so I'm just gonna call it Java, that file. So you might ask yourself, okay, what's the point of having all of these things? Like, why do we need why is there Java? Why is there Python? Why is there C++? Like, what's the whole point of it all, right?
Yeah.
So the point of it all is let's look at what the role of a computer is. The computer was mainly created to simplify our lives, right? To make our lives easier. For example, if I were to ask you right now to multiply, let's say, for example, to multiply in your head from like from your head, multiply this number. Let's say 3,233,000, right?
Yeah.
Times 3,459. Give me the answer right now. You
Yo.
see,
Yeah,
it's a
that's a track.
problem. It becomes a huge problem because now there's a there's limited things that our brain can perform, right? So
Mm.
you'd have to do the long way, like you'd have to write it down on paper and do this, and then you say 3,459, and then you multiply starting from the most right digit on the right hand side. You multiply, you add. Yeah, it's gonna be a very long process, right?
Yeah.
So that's why we have things like calculators, right? And remember, calculators were programmed. They were made they're made by developers, right? To make our lives simpler. Because if I open a calculator right now, right, and I type the value that I wanted you to calculate. I forgot what it was, but yeah, okay, three million two
3
hundred
million
and
something.
thirty-three
Yeah.
thousand, right? Times 3,459, right? There we go. I have the value fast, quick, no
Yeah.
problem. So those are one of the reasons why we needed computers, right? To make our lives easier, to simplify things. There's very big values that our brain cannot comprehend. We cannot calculate, and it's gonna become very tedious for us to calculate it on our own. So that's why they made computers like, okay, let's make the lives of people easier so that they don't have to stress about trying to find values and trying to calculate, trying to do this. It's basically to make our lives simpler, right? To make our lives easier. So for example, if you remember back in the days, right, if you check history, our great grandparents, they used to communicate via email, right? So they would write down on a piece of paper and then send it. They send the letter to that specific address, to that person they want to talk to, right? Even if it's like a hi. So they would type hi on the letter, send it to that person, and it would take weeks for it to get there. And then that person would also respond back and say hi, which would take a few more weeks to come back. So you see that the communication it becomes very
Inefficient.
tedious, and
Yeah.
it's inefficient. It's bad. So that's why they end up making apps like Instagram, WhatsApp, Twitter. things like that to make our lives easier. So that's the whole purpose of a computer, or the whole purpose of programming languages and programs and everything related to computer science, to make our lives easier. So since it's meant to make our lives easier, why do we need programming languages, right? The reason why we need programming languages is we can't use our native languages, right? Whether it's English, Spanish, Zulu, Tsonga, whatever language your home language is, you can't use that language because there's gonna be a language barrier, right? Not a
Yeah.
lot of people speak that language. First things first, right? Not everyone speaks your language. It's your language for that specific tribe, right? So one might be like, oh, okay, but there's English. English is everywhere in the world, right? Yeah, it is, but it's also problematic because in English, one word can have multiple meanings, right?
Mm.
You can you can have one word that means a lot of things, right? If you remember in English, one word can be used in different sentences and it would mean something different in every single situation. So you'd have to look at the context of which the word was used in. And if we have to do that, then it becomes hard for us to give the computers instructions, right? We
Yeah.
can't tell the computer what to do if the language is flawed. You see?
Yeah.
So you, for example, what word can I use? But you know that there's those words, just that I can't think of it right now at the moment. But there's words whereby that word has multiple meanings. It's one word, but if it's used in different scenarios, it means something different.
Yes. Yes.
Yeah.
I forget the word also. You used the example on your YouTube video. I did watch that video on your YouTube.
Yeah,
Yeah. Because
I did explain there. So
yeah.
yeah,
Yeah.
so that's the language barrier, right? So
Mm.
this is us, right? Come on. I want to change this name. Okay, so this is us, right? Human beings. This is us, right? And then
Yeah.
here's the computer on the side, right? Here's the computer. We are trying to tell what the computer should do. So we've already established that English is not a good language because one word can have multiple meanings and the computer might use that word out of context.
Yeah.
Yeah, so for example, if someone you say, like, for example, the word kill, you can kill someone, right, to take their lives. Or you can say, hey man,
Mm.
you're killing me with those jokes, man. You see, it's the same word, but
Yeah.
it means something different depending on the context of which it was used in, right?
Yes.
The
Yes.
computer can tell the difference. It'll be like,
Yeah.
oh, you're killing me with those jokes, and it will literally kill the person. Imagine you made an AI, like an artificial intelligent being, like a robot, right? That that
Mm.
that that is that's shaped in that takes the shape of a human being. So obviously it's made of out of metal, right? So it can kill a human being. And you put in those instructions using English, it will take it out of context. It'll be like, oh, um, uh, for example, when you say there's this word shoot, um, like or this, yeah, or let's use the word kill again. If, for example, you're about to say something and then you say, kill me if I'm wrong, the computer will literally kill you if you are wrong.
Yes.
So, so it becomes problematic. So we have already established that English is not a suitable language for us to give the computer instructions. Because another reason why we have computers, their role is for us to tell them what to do. They should perform a specific task. So English is not a good language for us to give instructions to the computer. We've already established that. Then we have the language of the computer, right? What if we wrote it in its own language? We wrote instructions in machine code. We wrote it using machine code. The problem is that machine code is very tricky because it uses binary zeros and ones. So imagine this is equivalent to saying hi, Can you please go buy food for me, right? Let's say you're trying to write this command, right? And the equivalent of this command, let's say H is something like this. That's what H stands for. And then I stands for something like this, right? So already you can see that it's already problematic. How are you going to remember that, okay, this set of digits represents H? And imagine you're having to type it down. So now let's imagine you've typed it down like this. Let's say this is the instructions, right? By just looking at this set of zeros and ones, can you immediately tell me translate to English?
No.
You can't. It will take you. And imagine, you know that in English we have paragraphs, there's essays, it extends, there's books. Imagine the whole book is written in like this. And to make it worse, imagine there's no spaces. Just imagine there's no spaces. So
It's
this is
just
in
tedious.
English, right? This is in the machine language, machine code. So it becomes very difficult for us human beings to comprehend the language. Same applies with the computer. The same applies to the computer not being able to understand English. Also, for us, it becomes extremely hard to understand its language, the machine code. We can't. It will take like years, and you will never perfect it because you're gonna keep having to refer to the documentation and everything. So we can already see both of these languages are hard. Our language, the human language, is difficult because it's tedious because one word can have multiple meanings. The computer's language is complicated because it uses binary, and sometimes there's keywords like there's keywords like this. Like now there's I think SH or something like that. There's those keywords, so it becomes very complicated. We can't speak that language. So what happened is that programmers sat down and they're like, okay, why don't we have a trade-off? Let's take the best of both worlds. Let's take some of the features from the computer language and some of the features from the human language, right? And make a trade-off, right? So there's going to be like an in-between language, right? It takes some of these parts and takes some of these parts to formulate what we call, okay, let me do this. To formulate what we call a programming language. In essence, it's basically, remember, programming is just the art of making programs. And what is a program? A program is just a set of instructions or a set of statements. So we can view a program in terms of, for example, an essay, right? We can say an essay it consists a set of sentences, right?
Yes.
Yeah, because an essay consists of sentences. So it's the same thing with the program. A program consists a set of instructions. We don't call them sentences. We use a different terminology, call them instructions because we are instructing the computer to do something. It's different from having to write essays. You're not instructing anyone to do anything, right? With an essay. It's just a sentence. You're just explaining, writing a story, telling a story. That's all you're doing. You're not telling anyone what to do. But with computers, we're instructing them to do something. So therefore, each sentence or each statement is called an instruction. So they made a trade-off between it took some of the features from the human language, which is English, the commonly used one, English. Remember what he said. We can't just say, okay, we're gonna take some features from Spanish. That's also gonna be hard because that means everyone must start to learn Spanish. It's easy for Spanish natives to understand it, but everyone else is gonna have a problem because now everyone else has to go and learn Spanish. So why don't we just use in a language that's already common in every country, English? So they took some of the features from English or some of the words from English, and then they took some of the features from the computer language, and we combined and had what we call a programming language. And then now you're going to ask yourself, if that's all there is to it, why do we have so many programming languages? The reason is that no programming language is perfect. Some languages are good in terms of speed. Some languages are good in terms of syntax, like they're easy to understand and easy to read for beginners, but they are slow. So it's always like that. Like Python. Python is very easy to understand. It's very close to English. It's very easy, but it's generally slower than languages like C and C++ and Fortran. It's very slow compared to those languages. But if you go to those languages that are fast, they are very hard to master because there's things like pointers. If you remember pointers in C++, nightmare. That thing is very terrible. You forget one small thing, you forget to deallocate. You're gonna have errors everywhere. Then you'll be confused, like what's going on? Why is my program doing this?
You put
So
a dot instead of an arrow, and it's
yeah,
that-
and then it's
it's
complaining.
shy.
It's shy. So you'd have to you have to understand that's the case. That's what we're dealing with. That's why we have many programming languages. So remember what I said, C++ is a bit complicated, right? Because of pointers. So what Java did, or the Java developers, they're like, wait, many programs are crashing because of um undefined reference to what, because you didn't deallocate properly. So a lot of companies were losing millions and billions from those system crashes, right? Remember, when a system crashes, even if it's a small bug, a company can lose like 20 million just from that small error. So that's why they developed languages. Programming languages kept on evolving so that they avoid such scenarios. That's where Java came into place. It was like, wait, C++ is fast, is good, but pointers are a problem. So let's improve the language. Let's create a language that's a bit more. It's almost as efficient as C++, but it's way easier. There's less errors that are gonna. It's less error prone. That means there's less errors that can occur in that language. So it was less error prone. That's Java. So there's less chances of you getting errors in Java because pointers are managed automatically by Java itself, by the compiler. You don't have to worry about pointers. It has pointers, but they're behind the scenes. It deallocates and allocates on your behalf. So just that's the beauty of Java. So that's why if you check a lot of companies these days, they use Java. Any company that you meet, Java is somewhere is somewhere in the development hierarchy, whatever, somewhere in the development part of the development stacks, the tech stacks. It's somewhere there because Java is used to make it's used the networking and mobile apps. Remember, Android is built with Java. So yeah, even Android apps are built in Java. So yeah, but Java is was very was always been a very efficient language. So as the programming language we're going to be learning is Java, right? That's the
Yes.
in-between language. So what's Java all about? Java is what you call an object-oriented language, right? You might ask yourself, isn't it the same as C++? I mean, C++ we had we had object-oriented programming. Well, in C++, it was an ex it was like an extra thing. It wasn't like something that comes like it's not like something that's really mandatory for you to write a Java a C++ application. It was just an extra concept, right? Remember, C++ extended the C language, and C by default it was a functional language. Functional language, in simple terms, we are saying that the language uses functions. It's based on functions. Java is based on classes. That's when you say object-oriented programming, it's based on classes. So even if you write the main function, it needs to be within a class. That's Java. It's object-oriented programming. Why did they do it like that? Well, the authors of Java, they viewed everything in terms of objects communicating with one another. right? Remember, programming language, in a way, they're trying to mimic the real world that we're in, right? It's trying to mimic everything we have in this real world. So we have chairs, we have desks, we have pencil cases, we have phones, we have laptop, we have all these things, right? So it's trying to mimic that. So if you view everything around you in terms of objects, that means an object is communicating with another object. So that's the concept that Java applies. So for example, if you're drinking water from a water bottle, right? Java or the Java developers, they would view that as the water bottle is an object and the person is an object. So an object is communicating with another object. So hence object-oriented language. So they view everything in terms of objects communicating with one another. So therefore, everything that you create in Java needs to be in a class. Keep that in mind. Everything in Java needs to be within a class. If you remember C++, again, you didn't have to write a class. You just say int main, right?
Yeah.
And then you say, yeah, and then you run your program, done. Is this thing within a class? No, it's not.
No.
So C++ is a functional language because it extended C, of which C is a functional language. So therefore, C++ also will have to be a functional language. Object-oriented is an extra feature that was added there. So when you say extra feature, all I'm saying is that when they were planning to make the language, they didn't say, okay, we're gonna make object-oriented programming as part of the language from the get-go. That's the difference between C++ and Java. With Java, when the authors were making it, they're like, no, everything needs to be within the class. So from the get-go, they thought of object-oriented programming. So that's the difference between C and Java, C++ and Java. C++ is mainly functional, based on functions. So you can create a file and put only a function and it's gonna run. With Java, you can't put a function because it's object-oriented programming. It's an at the base level of Java, everything is viewed in terms of classes or objects. So you have to place everything within a class. So yeah, they loved Java. They created Java, and the reason why it's loved is because there's many reasons. It's secure. Remember, there's no pointers. You don't manage them yourself. So that means it's very safe. It's secure. It's robust, right? And what else? There's many reasons, but it's safe. It's safe, secure, robust, and there's this thing. What is it called? Um, it's platform. It has platform independence. So that means the same Java program can run that I ran on Windows can run on Mac on a MacBook, on Mac OS, and on a Linux distribution system. So it runs the same. But with C++, it depends on which operating system you're using, right? All other languages. It depends on which operating system you're using. And things are done differently depending on the operating system. So Java is secure, robust, and it has platform independence. And it has this. The reason why it has platform independence. They took into account that Java should follow a what do you call a WARA philosophy. What does this mean? WARA stands for write once, run anyway. So you write Java code once. You can run it anyway. You don't have to write Java for Windows system and write Java for Linux and write Java for Mac OS. No, you don't do that. You do that with other programming languages like C++, C, Python also, I think. Yeah. So all the other languages, you do that. With Java, you write it once. So you don't have, imagine you're a company, right? And you're hiring developers and you're using Java. It's very efficient. You just hire one developer. You don't have to hire 3 developers. You don't have to hire a developer who's been using Linux or any Linux distribution, or who has been using any Mac OS, and another developer who has been using Windows their entire life. So you don't have to hire 3 developers. You hire one developer who's good in Java. and he writes the code once on any system that is comfortable in. And it's going to run the same. It's going to run anyway. It's going to run the same on any platform. That's the beauty of Java. So just keep that in mind. So that's Java. It has all these things. So how would you write a Java program, right? So let me see. Let me open. I hope I didn't still not opened that thing. I see now. Okay, let me not use this then, because it's gonna waste time. Because now I'd have to log out here because I was doing something else here. I thought it's gonna enter when it enters. I would have logged out already, so it's fine. So let's do this. Let's use Notepad++. I'm gonna create a new file, right? And with Java, remember what I said, everything is object oriented, right? So everything is
Yes.
placed within a class. So if you remember in other languages, right, when you save that file, you don't have to worry about the name. You can name it anything. But with Java,
Yeah.
the way you save the file, it should match with the class name within that file. So if I have a class, right, and it's called hello, that means I'm going to have to save the Java file as hello.java. Failure to do so is not going to run. It's definitely not going to run. So you need to be aware of that. That thing is very important. Use whatever class name you've written, even the capitalization and everything. If you write a small h here and you say hello, and you save your Java file like this, because remember when you say hello.java, what it does, it runs it through what we call a Java virtual machine, the Java JVM. So it's going to be run through the Java virtual machine. So the Java virtual machine, right, it expects your .java file, the name of your .java file, to match with the name of the class within that Java file. So failure for those things to match is going to complain. So what is a Java virtual file, right? Let me show you how. Let me show you the process of how it compiles how Java compiles its code, right? It's very different from our C++, where you have to what's that thing? Preprocessor directives and what all those things. Yeah, it's very different from that. It's very simple, to be honest. So with Java, right? So let's say you have your file here, right? This is your file. So let's call this hello.java, right? Or hello world. It's a hello world program, right? .java. There we go. Hello world.java program, right? And we've written the code. This is the file, right? And then what happens is that we call what we call the Java compiler. So the Java compiler is called using this command Java C. The C inside here stands for compiler. So therefore, in full, Java C stands for Java compiler. That's what it stands for, but they abbreviated to just Java C. So you're gonna call the Java compiler. So remember, you might ask yourself, why am I compiling? We are hearing the term compile, compiler. What are we talking about here? Remember when you talked about the languages, right? The language barrier. Let me undo. Remember the language barrier, right? So this language, that the programming language, it's neither English and it's also neither machine language. So that means the machine language is not going to understand it, right? So therefore, we're going to need here in between here, we're going to need a middleman, a translator. That's what we're going to need here. The middleman is going to translate. So this is a translator, right? And the translator, another term for it, remember, programming has its own terminology. So another word for translator, we call that compiler. So imagine you speak Sotho and you meet another person who speaks, let's say, Venda, and both of you are stubborn. You don't want to learn other languages, so you've only spoken your native language. So obviously, there's going to be a language barrier. You're not going to understand each other. Therefore, there needs to be a translator who knows both vendor and Sotho, right? So he's gonna listen to what you have to say in Sotho. He translates it to vendor so that that vendor can understand what you are saying. And then the vendor responds in vendor, and then that translator translates vendor to Sotho, and so forth. So he keeps translating and translating back and forth. So that's where the compiler comes in place. That's why the compiler is very important. So that's the compiler. It comes in between there. So there's the programming language. Okay, yeah, I'm gonna put the the person there. So there's the compiler, there's the compute. So the compiler or the translator translates, and then the same applies to, okay, okay, arrow like this. So the programming language is written, and then it's passed through the compiler or the translator. Then the translator translates the language to what the computer can understand, because the computer can only speak machine code, zeros, binary zeros and ones. So there needs to be a translation that takes place. So the compiler that we have in Java is what we call it's the Java compiler, and there's that code. So what happens is that, okay, so let me also add this. So the programming language, the code that you write, right, is going to be inside a file, right? Let's say we call it hello.java, like this, right? There's the file. It's written in this programming language. So let me make the arrow here so that we can see that it's written in the programming language, right? So it's written in the programming language. Come on. Oh, okay, I see the problem. Okay, let me do this. Yeah, there we go. So the programming language, right? We write the set of sentences or instructions and save them into a file with the .java extension, so that the translator knows, oh, okay, this is Java code. So it's going to interpret it as Java code, as part of the Java language, right? And then it gets passed through the Java compiler, right? And then it goes through what you call I don't know which shapes to use here. I'm just going to use any shapes, man. So it passed through what you call the Java compiler. So we use the command Java C, right, to compile or to translate. That's the translator. He's going to translate it to the language that the computer can speak. So that code goes through the Java compiler, and then the Java compiles it, and it spits out into the language that the computer can understand. It spits out a file with the .class extension. That's binary, and it has the same name. If it's hello, then the class file is going to be hello.class. So this file, it contains the binary language, or the machine code, the language that this computer can understand. So now it's going to be like, oh, I can understand. There's the file. But we need something, or we need to run it on somewhere, right? Remember that in C++, right? The C++, it runs the code onto your operating system, right? It runs it inside inside Windows, right? So remember Java, what it said, it follows the Wara philosophy. Write once, run anyway. How does it achieve that? So instead of it running on your operating system, it runs through a virtual machine, sort of like an operating system in the cloud, something like that. It's not physical. It's a non-physical operating system, something like that. You can call that it's called JVM, the Java Virtual. You can hear the word virtual. That means it's non-physical. Virtual machine. It's an you can view it as a computer that's in the cloud. So that's how you can dodge this thing of having to for you to have to write Java code for different operating systems. No, you don't. As long as that operating system is JVM, even if you write it inside Windows, you can output the same thing on a MacBook and on a computer with the Kali Linux or Ubuntu operating system. So there's the binary file with the machine code, right? So we need to interpret it. We need to execute what's there, right? How do we execute what's there? Remember, to execute the binary file, we need to run it inside the operating system. So instead of us running it inside the operating system, we're gonna run it inside what we call a JVM, Java Virtual Machine. So it gets passed through Java Virtual Machine. Here is the JVM, Java Virtual Machine, right? We pass, and remember the Java, always take this, just take this note this down. The Java Virtual Machine only reads or interprets binary files. Like, not necessarily binary files, but let me say files that are written using in machine code. It only does that translation only. You can't try to run a .java file via JVM. That's why I'm showing you this flow. It starts in a Java. Let's say your hello world, your hello.java program, right? The code is this one. It's supposed to print, right? I won't write all of the code in it. I'm just gonna write some of it. Let's say it's supposed to output so system.out.print hello, right? Hence I called the file hello.java because it prints hello. So this is the code. But remember, it doesn't know what system.out.print means. It doesn't know. We need to translate it into its own language. So that's where the Java compiler comes in place. It translates, it creates a binary file or a file with machine code or a file with the translated to the language that the computer speaks. Then you run that file via the JVM. And the JVM is non-physical. Always remember, it's non-physical. And the hint to always remember that is the keyword virtual. Can you see, is something virtual? Is when you say something is virtual, are you saying it's physical? No, you're not. You're saying it's non-physical.
Yeah.
So always keep that in mind. So after it goes through the JVM, that's when you see it's a long process, but it's worth it because we don't have to we don't have to understand the language of the compute. And then outside here, that's when it prints hello. So it's a very long process, but eventually you get there. And then it prints hello. And if you make changes to your hello.java file, you have to go through the same process again, compile it again, because there's new code that you've introduced. So you need to compile it again. It generates a .class file. You pass it via the JVM. Then it does what it's supposed to output. So that's the whole process of running Java programs. You create a .java file, and then you compile it, C or the Java compiler, and then it creates a binary file or the file written with machine code or written in the machine language, the language that the machine speaks. And then you execute or you run that file with the machine code via a JVM because Java's goal was to make sure that it maintains platform independence. So if I run it physically on Windows operating system, that means that code that I've written inside the Windows will only work for only Windows operating system. That means I'd have to rewrite my Java if I'm using a different operating system. So in order for it to maintain that, you have to use what we call a JVM, the Java Virtual Machine. It runs it on that virtual machine. So if I want to run the same code inside a MacBook, I just make sure I install Java. It comes with the JDK, the Java Development Kit. It comes with the JVM. And then I just run my hello.java. I send it to myself via email or via WhatsApp, that hello.java file from my Windows system, right? And then I download it into a MacBook. And then I just execute it on a MacBook, it's going to output and work exactly the same way. I don't have to translate it or do all of those things. Because why am I saying it becomes different? Because remember, operating systems have different philosophies. So Windows, it uses, if you have an executable file, it saves it in .exe. With Linux or Mac OS, because remember Mac OS, it's under the hood, it works the same as Linux. So it's Linux and Mac OS, it's in essence, it's the exact same thing. So it's like this, it saves it in .out. So you see, it's totally different philosophies and totally different approaches. So if you write code for Windows in C++, you must write code that works with Linux or Mac OS. So it becomes problematic. So Java, what it did, it avoided this thing of having to run or execute the the binary file or the file, that the translated file. It avoided having to execute it on the physical machine. Instead, it used the virtual machine. We call that the Java virtual machine. And then that's all you have to know about Java, the philosophy, how it compiles and everything. That's the important thing that you have to know about Java. So now, since you understand this whole procedure, right, let's create a simple Hello World program in Java, right? So let's do that. So a simple Hello World program. So let me save this file. Okay, I see. No, I don't know why I'm using Notepad. I have brackets. I have this IDE code brackets. It's sort of like VS Code, but it's old school. It's been there. It's made using HTML, CSS, and JavaScript. So I'm just gonna create a new file, and then I'm gonna choose the language here at the bottom and say I want to write in Java like this, and then I save it. Control S. Automatically, it's gonna add the .java extension. You see, automatically it added .java. But if I hadn't said change the programming language, it wouldn't say .java. So let's save it under downloads, right? And remember what I said. The way you name your files, it should be the name, the exact same way you're gonna name your class. So my class, I'm gonna name it hello. It's gonna print hello world, but I'm gonna name it hello because I don't want to have to type hello world in full. It's gonna take time. So hello, right? And then I click save. And then there you go. You see here, it is renamed, it has changed. So remember that in C++, right, you just say int main like this, right? Because it was based on functions. In Java, you also have a main, just like any other programming language. They all have a main function. But in Java, remember, it's object-oriented. So I would have to create a class, and then within the class, I add what is this? The main function. So let me zoom in a bit. So I'm gonna create the class first. So public class, the name of the class, remember, it should be the same name as the way I'm gonna save my Java file. So I called it hello. So I'm gonna call it hello. Don't remember, it's case sensitive. You can't write this and expect it to work. This is that hello is in all caps. It's in uppercase. I can't write it like that. I need to write it exactly the same way as I've saved the file. And then I add curly braces to say that everything that I write is going to be part of this class. Anything within this open curly braces and this closing curly braces is part of this class called hello. So let's create a main function, right? So I'm going to say public static void main. Okay, I'm going to run out of space now. So let me reduce the font a bit. So main and then string, an array of strings, and it takes in arguments. This is for, remember, command line arguments. This is for command line arguments. Okay. So you're gonna see a lot of things here, and you might ask yourself, what do these keywords mean? What does class mean? What does static mean? What does void mean? String, you have a bit of an idea. String is a data type. So what does public mean?
Although I am very interested on the string part because the last time I watched your YouTube video, you did say there's a lot to it, also with the capital S on it, something.
Yeah.
Yeah.
Yeah, you see the difference, right? So in
Yes.
Java, right, there's two types, right? There's what we call primitive types, right? These are we can say these are the basic types. These are your, e.g., your integer, your double, your float, your boolean, your notice something. I hope you're paying attention. Look at these data types, the way I've declared them. Isn't it exactly the same way they're declared in C++?
It's the same.
Is the same, right? So
Yeah.
the main goal of Java, the Java developers, when they sat down, they're like, no, we are tired of pointers. Let's create a different version of C++, but it's going to remove all the negative things of C++. So no more pointers, no more what. And so that's why you see the data types exactly the same way as they are declared in C++, because Java was trying to improve C++. It was not trying to take over and continue. No, they were creating something different from it, of which is way better. So if you remember all your types in C++, they are the same here, except for the string. String
Yeah.
by default is an uppercase letter. What does this uppercase letter mean? It means it's a class. That means you can call functions on that variable. So just keep that in mind. So these are your primitive types. So everything primitive types, it's in all lowercase letters. So we have bool. What's the other one? Char. You have your char, your character. Then we have what we call what are they called? I forgot the actual term for it, but we have what we call the other term for it is wrapper classes. So it's data types, right? But those data types, they belong to a class. So they always start with an uppercase letter, and they are all usually written in full. So integer is written as integer in full. So this is a whole class on its own. And then we have double in uppercase, the uppercase letter, and we have string. Like I said, strings are not gonna necessarily, we're not gonna pay too much attention on them because string is its own. You need a separate class for strings. There's a lot to do with strings, man. A lot. There's a lot on strings. So
Yeah.
we're not gonna dwell too much on strings. We wanna use it, but not dwell too much on it. So we have these types. So it's like this. So when you see the string like this, it's an uppercase letter S. It means it's a class. I'm calling a class, the string class, not the string data type. If you are
Okay.
using data type like this, you can't call functions on that variable. So for example, if I say int n is equals to 10, I can't say n dot
Yeah.
because that's a data type. But if I say integer y is equals to 100, I can say y dot because this is a wrapper class. You see, wrapper classes, it's a class. These are all classes. So just notice that difference. So when you see that capital letter S there, that's what it means. It means it's a class. So it means you can say dot and call functions. Now you can understand why I said strings, you're not going to pay too much attention on them because there's a lot of functions part of the string class. So
Yeah.
string data type or the string class, it's a whole class. It's a separate lesson that I'm going to get to it later. So let's look at this. So this is how you declare, right? So let's explain each keyword so that you can understand what's going on. Remember what I said about curly braces? It means that it's part of that thing. For example, if this opening curly braces and this is the or closing curly braces, it means it's part of everything within this curly braces. It's part of the class called hello. And then this function, this opening curly brace, and then this closing curly brace, it means it's part of this main function, this function called main. So let's explain these keywords. What is public? What is class? What is static? What does void mean? So I feel like void, you're gonna really understand it because I'm always gonna use the same example. So let's start with public. Public, you can view it the same way as a public transport. So that means it's free for all. Everyone has access. It's like a bus. You can't have a public transport and say in someone, or let's say a taxi, right? You're trying to hail a taxi, right? You're trying to get on a taxi. So you can't someone can you can't stop the taxi, right? And the person wants to get in and you tell them, no, this is my father's taxi, you can't get in. No, it's public transport. That means it's accessible to the public space. So everyone part of the public has access to it. So that's the public. It has the same meaning even in programming. Remember what we talked about, this trade-off, that the programming language takes some parts of the human language, of which is English, and some parts of computer. So the same way you define public in English is the same meaning it has here. Then you have the keyword class. If you remember class, this means that create a blueprint or a plan. I'm just when you use the keyword class, I'm saying I'm gonna create I'm gonna make an object. But before I build the object, I need to create a plan. So this is where your architects come into place. For example, you want to build a house. So the architects they make the plan, right? So this is where you see the word class, it means that the architects are busy making the plan. They're creating a blueprint, measuring where and stating where the kitchen will be, how many floors, this and that. Will it have a staircase? Will it have an elevator? Like all those things. What is the color, the interior color? What is the exterior color? All those things. That's the blueprint. That's what the keyword class means. It means I'm creating a blueprint or a plan for an object that I'm going to build. Remember what I said about object. Object is anything that you can see in front of you. A water bottle, a computer keyboard, your wallet, your bank card. That's if you view it in terms of objects, that means all of those things are objects. So even a house is an object. So if I use the keyword class, it means I'm creating a template. I'm creating a blueprint or a plan for an object that I'm going to build later on. That's what class means. And then we have static. Static can be interchangeable with the word shed. It's synonymous with the word shed. So it's like a synonym for shed. So it's shared. We are sharing this thing, right? So you can imagine, for example, you are twins. Imagine you have a twin, right? Obvious, if you are twins, you wear the same size, you have the same height, same shoe size, same everything, same face, everything. So if you wanted to cut down the costs of spending, right? You wanted to cut down your expenditure, right? The way you're spending. You could buy one thing, or for example, for example, you find one thing that you both like. You like the same thing. Let's say it's a pair of jeans, the same jeans. You both like the same pair of jeans. What you can do is instead of buying two jeans, remember this is the exact same jeans, same size, same color, same price, same everything. So instead of buying two jeans, you'd rather share that one jean. You'd go 50-50 and buy that one jean. On a specific day, one of the other twin wears it, and then on another day, the other twin wears it. Or I can use the example of a piggy bank, right? So, okay, let me wait for this thing to go up because now it's affecting me. I can't create a new. I want to create a new tab. Let me do this. Okay. So let's say you have a piggy bank, right? Let me just show you how a piggy bank looks so that you can understand, you can picture what I'm picturing in my mind. This is a piggy bank, that thing that you use to store your coins or your money to save up money, right? So imagine you and your friend or your friends, whatever, or your roommate. You want to save money, so you decide to buy a piggy bank. Instead of buying two piggy banks, you're gonna use the same thing, right? And both of you are doing the same thing, you're saving. Why not buy one piggy bank? Both of you guys put in the money there and you share. That's what static means. It means instead of each object having its own copy or its own version of that thing. For example, like I said, remember each thing in this real world can be viewed as an object. Even a person can be viewed as an object. You can call that the person object. So you can go back to that example about twins, about wanting to buy a pair of jeans. So instead of each object or each twin having their own version of the thing. You can create one version of the thing and then it gets shared amongst all objects. So imagine your triplets or your quadruplets, whatever, your twins. There's that common thing that you guys have. So you wanna, instead of buying the same gene, each one has their own gene. You can contribute money and buy one pair of gene and it gets shared amongst all of you guys. So that's static. It's synonymous with the word shared. It basically means sharing. So I hope that makes sense.
Yes.
And then you have the void. This one is easy to explain. Void basically means that there's nothing there. It represents nothing. It's a state of nothingness. You can imagine void is like, for example, when you go to Pick n Pay, whatever, I think it's usually ShopRite. I think it's ShopRite. Yeah. You go to ShopRite and you want to buy something and then your card declines. Then they call Prudence. They're like, Prudence, void, yeah, decline. What does that mean? It means nothing happened, right? They're expecting to
Yes.
withdraw money from your card, but void happened. That means nothing happened. So when you see void, think of Prudence and calling his workmates, her workmates, um, and calling them and saying your card is declined, right? And they say void, the card declined, void, Prudence, void, card decline. Always think about that when you see void. So now you understand everything that's part of every Java file. That is the main function. That's what it means. When you see static, that's what it means. So we understand Java, right? We understand all the words that are there. So let me just save this. Like, let me leave the comments there. Oh, by the way, this is how you do comments. It's the same in C++.
Yes.
The way you do comments in C++ is the same here. The only difference is that there's an extra comment. Okay, this is the first type of comment. 2 backslashes, right? No, is it not backslash, forward slash? So 2 forward slashes, and you can also say forward slash, asterisk, and then another asterisk, and then forward slash, and then you start typing here.
Oh.
This is what you call a multi-line comment, right? It spans on multiple lines. So for example, let me show you what it means by multiple lines. I can do this, you see. This is a comment, another line. I can still comment. This is a single line comment. It's in the name itself. It's single line. It's just a single line of comment. And then we have the last one, which is called Java doc. I can just call it Java doc comment for Java. Java doc stands for Java documentation. So basically you explain what your class or your function does in full. You explain all the parameters. Oh, this parameter represents this age. It represents an age of a person. This parameter represents the height of a person. This parameter represents the weight, either in kilograms or what. That's JavaDoc. How do you do JavaDoc? You do it like this. You say /2 asterisks, and then you press enter, and then 1 asterisk at the end, and then /. And then this is now what we call a Java documentation or JavaDoc. And then you just keep pressing enter. Just that here it doesn't show properly because I'm not using an Eclipse. I'm not using a proper IDE. If I was using a proper IDE, right, every time you press enter, it does this. It adds an asterisk like this. So this is usually how it looks. It's just that I'm using a text editor. This is just a text editor for me to write text. A proper integrated development environment would autocomplete everything. You will see that as we go along, right?
Yes.
I can't feed you everything in one session. You're gonna have your brain is gonna be overloaded. So yeah. So this is different types of comments, right? Just be aware of comments. And then how would you output, right? Remember, the main goal of this application is to output and say hello, output hello. So I say system, I call the system class, and then I call an instance of print stream. Out, you see the keyword out. When I say .out, this is an instance of print stream. That means its main goal is for printing. It's like, if you remember, yeah, you see, that's why they like to reference C++. If you remember, this out is equivalent to you saying C out, right? You
Yes.
see, out, C out. And C out was an instance of what is it? O stream, right? Meaning output stream. Here it's not called output stream because it's Java, it's a different thing. It's called print stream, to print output. It's similar to C++, but just slight variation. So just keep that in mind. And then after creating that instance, right, now I can call functions within within the print stream. Those functions are .print to just print, and then .print line to print and then start on a new line. So move the cursor to a new line, and printf to print a formatted version of the output. So these are the most commonly used printing functions.
Oh, what does the formatted version means exactly?
So formatted, right? It's like I think if I can remember, it's like let's say for example you do this, right? You say %d. D stands for digit, so integer, right? And I say let's say this plus this digit is equals to some digit, right? And then I say comma, and then I start placing the number, the variables with those digits. So everywhere, the first parameter that I pass here is gonna replace this %t, right? Let's say it's n. So this will be replaced when it outputs, it's gonna put the n here like this, the value of n. That's what
Oh,
formatting means. And then I pass in another parameter, let's say k, and then j, right? Let me zoom out a bit. So n is gonna be, it outputs them in that order. So if n is the first integer you've passed it there, it's gonna say n, replace n, and then k is the second one, put k there, and then j is the last one. So it does that. So that's formatting output. But for now, we go into more details into print and whatnot. But for now, I just want to show you a simple Java application. So let me just use the print line, right? So I wanted to move the cursor on a new line after printing. So print line. So what text, what thing do I want to print? I want to print hello world, right? Okay, okay, it's fine. Hello world. So usually in every programming language that you get introduced to, you always have to output hello world so that you get a basic understanding of the setup of that language and how and its philosophy and everything. So this would be your first Java program. So how do we run the Java program, right? Let's now me and opening apps. It's gonna, but it's fine. I'll close it once it start opening. So let's run it, right? So let me close this window. This is a different Java IDE. So now, remember now I'm not using an IDE, right? So I need to locate where the Java file is saved. It's saved here, right? So just to make simple things simpler, right? I want you to really see the dot class. Remember we talked about dot class, né? I want you to see all of that. So that you don't say, this guy is taking chances. Maybe he's lying. I didn't see the dot class. Maybe it's just hypothetical. No, I want you to see it. So I'm going to save it inside this folder and just call it tutorial 00. Yeah. So I'm going to open my command prompt. Command prompt is what we call a textual, it's called what? a textual interface. So it's a interface that you use to navigate your operating system, but through text. You're not going to click. Remember all these apps, right? They use what you call
Yes.
graphical user interface. There's buttons in there. Command prompt, it doesn't use buttons. You just type text. So let's learn a few commands, right? So dir, it means list everything in this current directory. And okay, let me write notes while I'm explaining it. So dir, it means list everything in that current directory. So dir is just an abbreviation of directory. And so that you know what directory means. Directory is a synonym for folder. It just basically means folder. I know it. You might ask yourself, why didn't they just say folder? Yeah, that's how it is. They structured it like that. There's terminology for things. Just like in engineering, they use some other terms, whereas they could have used simpler terms, but it's just part of it's the terminology involved in that industry. Even in physics, when you get there, there's things like displacement and what. You'd be like, why didn't they use simpler terms? It's just the terminology for that industry. So same applies here. You just need to call it the directory, not folder. If you say folder, they'll be like, this one clearly doesn't know what it's doing. He's a beginner, this one. He's still calling them folders. It's called a directory. So dir means list everything in my directory, in the current folder. In this, how do I know I'm in the current folder? I look here. You see here, I'm in the THETR folder. That's the current folder I'm in. So it's gonna list everything inside that folder, right? Which folder is the Java file? It's stored in the downloads folder. So I have to move to the downloads folder. And there's a command to clear the screen. Remember, the screen becomes too full sometimes, you see. Now you can see there's a lot going on. You use CLS to clear the screen. And then you press enter. After every command, you press enter. So CLS, it means clear the screen. So this is where you can see the abbreviation CL and then S here, clear the screen or clear screen, however you want to call it. It doesn't really matter, but just know you're clearing the screen. So I've cleared the screen. I know which folder I want to go to. So now I need to change the directory. So change the folder that I'm in. So I say CD, which is an abbreviation for change directory. CD means change directory. So how do you change directory? You say e.g. you say CD followed by name of folder or the name of directory. Remember, we are now Englished. We don't say folder, we say directory. So name of directory. So this is the formula that you're going to use. So you're going to say CD. Let me zoom in so that you can see properly. CD followed by the folder I want to move into. It's the downloads folder. And remember the way it's spelled, it started with a capital D. So I need to name it the exact same way. And then I press enter. And then to see if I'm in the right directory, right, I can go to my file explorer and check everything inside of my downloads folder. You see, these are the full files. There's Python, algorithms, Insidious, what accounting. There's all those folders, right? So I'm gonna type that command again, dir, to list everything in the current directory. There we go. Let's go up. There it is, accounting, algorithms, Python. It arranges it in alphabetical order. That's why you don't see it the way it's structured in the file explorer. You see, so I know I'm in the right folder. And then I say CLS to clear the screen because I just wanted to confirm if I'm in the right folder. And another way to confirm, look, it changed. It's now in the downloads folder. That's the one, that's the name at the end. It means that's the current folder you are in. And to also check which current folder you are in, you can just say dir like this. It's going to write it down, which is exactly this thing here. So there's no need for you to know all of that. You can just look at what's written there. So I'm just going to clear the screen. And then remember, I need to also move into this tutorial folder because the Java file is inside the tutorial folder. I'm now in the downloads folder, but the thing that I want to, the Java file that I want to compile is inside the tutorial folder. So I'm going to say change directory again, right? And say tutorial. Usually, you don't have to type everything. You can just type the first 2 or 3 letters and then you press tab. It's going to autocomplete. So let me press tab. There we go. Auto-completed. And then I just press enter. And I can clear the screen and then I can say dir to check what's in the current directory. I should find hello.java folder. There we go. There it is. Hello.java. And this is its size. It's 440 bytes. And then I don't have to see all of these things. I can just clear the screen. So now how do we compile? Let me take back to the diagram. We said Java C. So we use the Java compiler. So what am I compiling? Is the name of that Java file. So what is it called? So I need to start by saying Java C. Is Java C, what it does, it calls the Java compiler. So before I can do that, let's just check if it's properly installed, right? So let me say Java C. I think I might have deleted. Okay, it's still there, but I have the wrong version. I'm gonna have to reinstall again. JDK 21. I'm currently using 17, but yeah, I'm gonna reinstall. But I know because I know it's installed because it's showing me the version, right? So I know it's safe to use it, to use the command. So Java C space, and then followed by the Java file, right? It's called hello.java. So what I'm saying is call the Java compiler. It calls and then it asks which file should I call the Java compiler on? I should call it on the hello.java file. And then just press enter. Now it's compiling. It's done compiling. And then if I press dir, I should see a .class file. There's the .class file. And you can go into the file explorer just to confirm. There we go. There's the binary version of this code. So remember, this is not okay. What's going on now? Oh, I changed. I moved it to a different folder, so that's why it disappeared. Yeah. So let me just say open. Remember, it was the Java file was not in a folder. It was previous not in a folder, so that's why it did that. So you see, remember that the computer language doesn't speak this language. This was a trade-off. It's a mixture. We've blended 2 different languages into what we call a programming language, and this is a Java programming language. So it's not the machine language. It's not the language that the machine can understand. So we have to translate. We have to call the compile. So the .class file, it contains the language, the equivalent language to the machine language or the machine version of the Java file. So if I say edit to Notepad++, just to see, you see how complicated it is.
Yeah.
There's the hello world. That's where it's gonna print this text. This is, you see, SOH, null, ETX. This is very complicated. Imagine trying to write in this language, trying to write a hello world program. And there's about 3/4. How would you type 3/4 here?
And
It's a
all of
problem.
this just for Hello World.
And this is just for hello world. Imagine
Yeah.
you're creating a big system like maybe WhatsApp. You made WhatsApp. Remember, Java is the language that's used to make Android applications. So imagine you made WhatsApp. Yeah, it's gonna be, you'll be pissed. You'll be angry at everyone you meet in the street. Everyone,
If you see even a single line of code on my computer, don't talk to me. I'm
yeah,
thinking.
you're thinking. So this is the binary version, right? So now I'm gonna use the Java. So remember, it's still not outputting hello world. I need to pass it via the Java virtual machine, the JVM. I have the class file now. So let's do that. So how do we do that? I just use the Java command. So what Java does in essence, it means run this Java code via the Java virtual machine. So I need to pass in the name of class file, but I don't write it in full. You don't write the dot class extension. You just write the name in front of the dot class. So if it's called hello.class, you just say hello. You don't put dot class. It already knows. It's gonna go and look for that dot class file, and then just press enter. There we go. Hello world. So if you add something, remember what I was talking about, that you have to recompile if you add something new. So let's say I say system dot out dot print line, and then I say hope you have a good day, right? And then I put a smiling emoji there. I save my changes and I run Java again, right? To rerun previous commands, right? On your computer, you press the up arrow. You see, I press up, it's going to look for the previous command. Up again, previous. Up, up. You see, all the commands that I've run. So I don't have to. And you can go down to go to the recent command. So I want the Java command. There it is. And then you'll be like, that's interesting. Why is it still outputting hello world when in my code I've added changes? Because you are running the previous translation or the previous translated version. You're going to have to compile it again so that it retranslates, and then you run the new translated version. So I'm going to run the Java compiler on this hello.java file. There we go. And then there's an error. What's going on? You must listen to the error.
Yeah.
Semicolon expected on line what? 15. Let's check the lines. Let's count. Okay, this is 10, 11. Okay, there's 15. Line 15. Okay, let me zoom out so that it makes sense why it says line 15. You see, line 15, what's missing? Semicolon at the end. At least I had followed the instructions. So let me press the up arrow to rerun the latest previous command that I've typed. Press enter, done. And then I can just say CLS because now there's too much on my screen. And then I run the Java command. If you check okay, let me say dir to list the files. Let's look at the time. 10 to 4. If I check here, this is now 9 to 4, but that means I have the recent translated version. Then I know for sure it did translate. And then CLS, because I need to clear the screen. And then I run Java on my binary file or the file that is the machine that is the machine code. And then I press enter. There we go. Hello world. Hope you have a good day. So this is how all Java programs are going to be created. So if you want to create our inheritance and what, you have to create another .java file for that class. This one is just the main class. It contains the main function. That's all it does. That's where you call that's how you create instances of the classes and all those things. But that's the main, this is the file that contains the main function. So I think this should suffice for now.
Yeah.
Because I don't want to overcrowd you with information, because I feel like what I've already told you right now, it's a lot to take in. You're gonna have to go and process. If it means rewatching the video, you're gonna have to rewatch the video. So yeah, this is the process of Java. Every Java program that you run, it's gonna do this. So usually what happens, what happens is it's sort of, okay, we'll deal with the many files when you have a lot of files. For now, we're gonna look at just one file. We're running one file. This is how the process that's gonna take place. So do you have any questions? Did you understand everything?
Yeah, I understood. I understood. I was also able to take some notes, so yeah, it's good. It's good.
Okay, that's
Yeah.
good, man. So I'm just gonna, but I'll see. I guess I'll have to upload the recording around 6 because it's gonna be load shading at 4 now. So I'm gonna, because it takes time to save the recording too. It might take 10 to 30 minutes just trying to save the recording. So I'm probably gonna upload it a bit late.
Yeah, no problem.
Okay, if no questions, then that's it for not today, but for this session for now.
Yeah, for now.
Yeah.
Away, man. Thanks.
Okay. Sharp, man. We'll see each other in the next session.
Away.
Sharp.